Hi there, math fans. I'm Dr. Andy Loveless. I'm teaching precalculus here at the University of Washington this fall. One thing about our precalculus course is all the problems are applied, and I would argue interesting. Now, students might feel a little differently about them, but one problem that's been in our textbook for years, this book was written by Dave Collingwood and Dave Prince, has Allison and Adrian attached at the ankles by a bungee cord. The whole point of the problem is just to work with coordinate systems and distance, but in this applied setting. I've always wanted to make a little animation, so I did. I threw myself in there. That's me connected to Harry the Husky. Let us go. So I'm just going to start animating this here. So here we go. We're connected to the bungee cord. Once the bungee cord gets to 30 feet, it's stretched, and then it will stretch further. That's the whole idea of this question. But eventually you hit the corner of that building. Okay, so I have a longer video where I talk about some of these pieces. I just think that's kind of interesting, gets us thinking. But the main thing is that the problem says that Allison's going 20 feet per second. So you can label her location 0, the y coordinate 0, 20t, and you can label the x coordinate. Adrian, is going 12 feet per second. And the thing I talked about is once you have those, the fact that we already have the distance formula, it's a quick thing. It's the distance between those coordinates. So I find some students are really struggling with just the fact that we're labeling in terms of this unknown t, but that's the skill we're practicing. 20t minus 0 squared, and then that's the distance between them, and that can be simplified dramatically to 144t squared. And there's several problems in a row where you do this like exact same thing, and you could even simplify that further to the square root of 544t squared, and even further. So you can get that the distance between Allison and Adrian, or me and Harry the Husky, is the square root of 544t. That's really nice. Then the question asks a bunch of different questions about it, and the big challenge that students are struggling with right now is when do I hit the corner of that building? And there's actually many ways to do it, and I've been kind of letting students struggle. You could maybe say something about the slope of that line and the fact that it goes through the point negative 20, 30. You could maybe use similar triangles. You could, once you find the distance, you'll be done because you can just take the distance and divide by the square root of 544. Okay, hope that gives you a little flavor of one of our applied questions.